Next topic, the Mellin transformation. So definition. The Mellin transform of the function f of x, where x lies between 0 to infinite, is defined by m of f of x comma p, which is equal to integral 0 to infinite x power p minus 1 into f of x dx. It is denoted by f star of p or m of f of x. Applications, there are so many applications. So simply just for an example, it is a tool for analyzing behavior of many functions in mathematics, right? In for example, number theory zeta function. Similarly, in physics example, quantum mechanics, it is used in quantum mechanics. In computer science, we are using to analyze the algorithms, right? Image recognitions, etc., 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 right? So Mellin inversion theorem, a statement, if m of f of x comma p, which is equal to f star of p, which is equal to integral 0 to infinite x power p minus 1 f of x dx, then the inverse transformation is given by f of x is equal to m inverse of f star of p comma x, which is equal to 1 by 2 pi I integral c minus I infinite to c plus I infinite x power minus p f star of p dp. We know the complex Fourier transform of the given function g of t is given by g bar of s, which is equal to integral minus infinite to plus infinite e power ist g of t dt. That is equation number 1. And its inverse transformation, that is complex inverse Fourier transformation, is given by g of t, which is equal to 1 by 2 pi integral minus infinite to plus infinite e power minus I ts g bar of s ds 2. That is equation number 2. Put t is equal to log x, that means x is equal to e power t, and put p is equal to c plus is in 1 and 2. So we will get t is equal to log x, that implies derivative of t, which is equal to derivative of log x, that is 1 by x into dx. P is equal to c plus is, that means is, which is equal to p minus c, multiplying by I square s, which is equal to ip minus ic. Therefore minus s is equal to ip minus ic, because I square minus 1. Therefore s is equal to multiplying with minus ic minus ip. So we are changing the limits from t to x, because we have taken t is equal to log x, so function is in x. So we are function is in t, right? So we are changing from t to x limits. When t is equal to minus infinite, that is x is equal to e power t. So e power minus infinite, that is equal to 0. When t is equal to infinite, x is equal to e power t, that is e power minus infinite, that is equal to infinite. So 1 implies g bar of s is equal to integral minus infinite to plus infinite. E power I ts can be written as e power t whole power is into g of t dt. So now we are replacing g bar of ic minus ip, which is equal to integral, limit is changing 0 to infinite. So e power t is x power is, g of t is log x, g of log x, and dt is 1 by x dx. So that is equal to integral 0 to infinite x power I, replacing s by ic minus ip, g of log x 1 by x dx. That is equal to integral 0 to infinite, taking I outside, so x power I square c minus p g of log x 1 by x dx. So that is equal to integral 0 to infinite, I square is minus 1, x power minus c minus p g of log x 1 by x dx. So that is equal to integral 0 to infinite x power multiplying with minus, so p minus c, and 1 by x can be written as x power minus 1 g of log x dx. So that is equal to integral 0 to infinite. So we are splitting the powers for our convenience. So x power p, and we are grouping with minus 1 x power p minus 1, and separating x power minus c into g of log x dx. That is equation number 3. So now we are putting x power minus c, g of log x is equal to f of x, and g bar of ic minus ip is equal to f star of p. In equation number 3, we will get f star of p, which is equal to integral 0 to infinite x power p minus 1 f of x dx. That is equation number 4. Now inversion part. So changing the limits right now from s to p. Now the function is in s. Now we are changing to p, right? Accordingly, we are changing the limit. S is equal to minus infinite, then S value is minus IC minus IP, that is equal to minus infinite. So minus IP is equal to, taking IC that side, so it will become minus IC minus infinite multiplying with I. So we will get minus I into I square P, which is equal to minus I into I square C, which is minus I infinite. I square is minus 1, minus into minus plus, P minus. Similarly here also minus into minus plus, C minus I infinite. Now when S is equal to infinite, IC minus IP is equal to infinite. Same procedure. So I minus IP is equal to minus IC plus infinite multiplying with I. So you will get minus I square P, which is equal to minus I square C plus I infinite. Therefore P is equal to C plus I infinite. Right now let we know P is equal to C plus IS. Therefore dP, which is equal to dc is 0, so I ds, therefore ds, which is equal to dp by I. Now 2 implies g of t, which is equal to 1 by 2 pi integral minus infinite to plus infinite e power minus I ts g bar as s ds, that is equal to 1 by 2 pi integral minus infinite to plus infinite e power minus I ts can be written as e power t whole power minus is g bar of s ds. Now we are replacing t by log x, g of log x, which is equal to 1 by 2 pi, changing the limit integral, lower limit c minus I infinite, upper limit c plus I infinite, e power t is x, x power minus is, g bar of s is nothing but ic minus ip, and ds is dp by I. So that is equal to, taking 1 by I, so dp by I, 1 by I outside, so grouping with that 2 pi, so 1 by 2 pi I integral c minus I infinite to c plus I infinite, x power minus I, s is nothing but ic minus ip, g bar of ic minus ip dp, that is equal to 1 by 2 pi I integral c minus I infinite to c plus I infinite x power, taking I outside, minus I into I square, c minus p, g bar of ic minus ip dp, which is equal to 1 by 2 pi I integral c minus I infinite to c plus I infinite x power I square minus 1 minus into minus plus c minus p, g bar of ic minus ip dp, that is equation number 5. So therefore g of log x, which is equal to 1 by 2 pi I integral c minus I infinite to c plus I infinite. So splitting the powers of x, x power c, x power minus p, g bar of ic minus ip dp, taking x power c outside because the integral is with respect to p. So x power c is a constant, so take it outside from the integration. X power c 1 by 2 pi I integral c minus I infinite to c plus I infinite, x power minus p, g bar of ic minus ip dp. Now multiplying both sides by x power minus c. So x power minus c g log x, which is equal to 1 by 2 pi I. So we are having x power c already, so multiplying with x power minus ic, so grouping the power, x power c minus c, x power 0, so that is 1. So 1 by 2 pi I integral c minus I infinite to c plus I infinite, x power minus p, g bar of ic minus ip dp. So let x power minus c g log x, which is equal to f of x, and g bar of ic minus ip is equal to f star of p. So this becomes f of x is equal to 1 by 2 pi I integral c minus I infinite to c plus I infinite, x power minus p, f star of p dp, that is equation number 6. So here 5 is the Mellin transform of f of x. Similar, so from that 6 is the Mellin inversion formula, because we have taken Fourier transform and its inversion, right? So from that only we derived, so 5 and 6. So 5 is Mellin, so automatically 6 is its inversion formula. Thanks.